So, very good morning to all members gathered here. Today, we are in the last lecture series, a design of bearing support under the course design of machine elements. So, before moving to the topic, let us go with the session objectives. So, bearing is considered to be the most sensitive, important machine element that strongly supports various moving parts, the connecting elements of the machineries. The primary purpose of using bearing is to control the friction between various mechanical moving parts in order to have a safe relative motion with respect to each other. Say for an example, consider a shaft and a bearing support. The shaft will be rotated very safely with the control of the bearing fixed at both the dead ends of the shaft. So this is one such example, shaft and bearing assembly. So bearing is highly essential for smooth running of machinery, starting from basic simple tools to complex systems like automobiles and aircraft system. Now let us go with the exact information what is required. So design of bearings. So the bearing design mainly influences selection of materials, determining the dimensions required for the bearing for the safe transmission of load and specifying the tolerance and fits to ensure the bearing performance and the long-term service life under specific load conditions and various operating environments. Among all, the most important key factors are load types, speed and material selection, as well as the lubricant materials that are used to control the friction between the moving parts. Let us see the further information in the following slides. Here are some of the detailed information about the bearing design as follows. According to the existing literature, the classification of bearings can be categorized into two levels, plain bearing and rolling contact bearing. Normally, plain bearings will have sliding contact with respect to the surface of the moving parts, but it will produce a high friction rate, whereas rolling contact bearings are more safe compared to the plain bearings because the surface don't have a direct touch. It has been controlled by the series of rollers or balls which is kept inside the inner race of the bearing housing assembly. So in return, it will reduce the friction by making them more suitable for high-speed operations and dead loads. The examples of rolling contact bearing here it is given deep groove ball bearing and angular contact ball bearing. So what are the general design factors influencing the bearing design? Load, speed and material. The most widely used material is high carbon chromium steel for the ball assembly which is kept inside the bearing housing. So which can able to withstand more heat and friction between the mating surfaces. For other purpose, high carbon chromium steels are most widely preferred. Next one is design considerations. Loading capacity, there are two types of loads will influence in a bearing housing, radial load and axial load. We will see in a simple numerical problem what is the difference between these two combined loads. Next one is the impact of friction and heat dissipation, then shaft and the housing design. So these are the main things to be considered under the bearing design. Now we will discuss this simple example. Consider a single row angular contact ball bearing with a given radial load of 2500 Newton and axial load of 1500 Newton, which is subject to a light shock impact load. The bearing dynamic capacity is given as 53 kilonewton. So before moving to the solution part, so let me give you the brief discrimination between radial load and axial load. So you can refer the figure in the right side. Radial load is nothing but the perpendicular, the normal force which is acting with respect to the axis of rotation of the bearing support. Whereas axial load is nothing but the horizontal force along the axis of the bearing. So these are the two loads will influence each other when the bearing is supposed to rotate. So now we have to find out the coefficient between these two loads by dividing axial load by radial load, 1500 Newton by 2500 Newton. So we will get a coefficient 0.6. Use that value and find out the value of X and Y from the design data book. So we know single row angular contact ball bearing. Refer the data book and find out the radial factor and thrust factor X and Y for the given the coefficient 0.6. So here the values are taken as X is 1 and thrust factor Y is 0. Use this to calculate the dynamic equivalent load W using this formula. Find out, we will get 2500 Newton. This is the calculated dynamic load. Now we have to find out the design dynamic load of the single row angular contact ball bearing. Assume the service factor for light shock load is 1.5 since in the problem it has been given light shock load. So multiply that service factor with the calculated W value. So you will be able to find out what is the design allowable dynamic equivalent load. So 3750 Newton. So from this problem, it is proven that the design is safe regarding the load equivalent calculation, dynamic load equivalent calculation. Since the calculated value is less than the design value, so the angular contact ball bearing, single row type, is considered to be safe. Likewise, we have to prove the remaining key parameters as I mentioned in the theoretical principles. With this, I quickly wind up the short course on design of machine elements with a closing remark. So by considering some of the basic, the key factors in the bearing design and utilizing the appropriate design methods, engineers can able to prepare the most highly resilient and robust ball bearing support that provide more reliable and efficient performance for a wide range of application. So with this conclusion, I thank each and every one of you. Thank you all.